So taking a look here, how much money do you have in your wallet, right? That's going to be an actual number. And so yes, that would be quantitative. Quantitative, perfect. All cats have brown fur. Brown fur is not something that is a number, a numerical piece of data. So yes, that would count as qualitative, meaning characteristic data. What is your favorite color? Color is also, again, going to be a description or a characteristic. It's not going to be a number. You wouldn't say, my favorite color is 7. That would be confusing. So that would count as qualitative data, all right? And then finally, how much does a new baby weigh? Again, you would give an actual number for this, like 7 pounds, 4 ounces. And so that would definitely be numbers. That would be quantitative. Excellent. So let me go ahead. I'll just match those up a little bit more cleanly so we can see that. So again, money and baby weight, that's quantitative. For colors are going to be qualitative. Excellent. All right, let's go ahead and make sure we have our notes open. If you want to go ahead and raise your hand already and let me know that you have your notes open, that's totally fine. Remember that you can get notes credit at any point throughout the trimester, but if you want the double whammy of both notes and attendance, then you do need to do your notes during class. That's how we check that you were here, that you were doing what you were supposed to be doing, and therefore you have earned your attendance. So again, logging in is not enough. You need to make sure you're actually doing your notes during class. So again, notes by itself will give you notes credit, but notes during class will give you notes and attendance credit, right? So make sure you're doing your notes during class. Cool beans. All right, let's go ahead and move on here. This is a reminder, please do not share contact info. Please make sure you're participating often and well and behaving appropriately. Don't forget that these sessions are being recorded. We are on day 7 out of 60. Today we are talking about our last topic of Unit 1. We're already done with Unit 1, y'all. That is crazy. So we are going to be talking about graphing. Yeah, there is. Yeah, I had a friend in high school who had synesthesia. So yes, they had some weird associations that seemed weird to me, but completely normal to them. Yeah. Tomorrow, please remember that we don't have live sessions. Instead, you will have a recording that goes over the rest of your project slides. So remember that last Thursday, I'll tell you this in the chat. Last Thursday, the recording went over slides numbers 1 through 6 of the Unit 1 project template. Again, that recording and that template that you need to use for your Unit 1 project are all in your grades tab, because everything is in your grades tab. Again, you're not making your own PowerPoint. You need to use the template that is provided in the grades tab. You need to use the recording that shows you how to use that template. Okay, Tomorrow we will have a recording that goes over the remaining slides. Okay, so that'll be what you should be working on tomorrow. You should be working on finishing up your Unit 1 project tomorrow. And then Friday we will be working on our newest unit talking about motion. Okay, so some announcements about our project. It is currently going to be worth over 70% of your grade. Now I know you're like, that seems like a really ridiculous amount, and I hear that, okay? But normally all of your projects together are worth 70%. But since your Unit 1 project is the only project in that category right now, it's going to count as the entire 70%. And in fact, it actually counts a little bit more than 70% because currently we don't have Star 360 in our gradebook. Star 360 won't be added until the end of the trimester. So all that being said, if you don't get your Unit 1 project in, you're going to see your grade drop to significantly below passing. So you want to make sure that you get your Unit 1 project in. That way your grade doesn't drop horrifically. Okay, go ahead, give me a smiley face or an emoji in the chat box, or a yes if that makes sense. Okay, your Unit 1 project is going to count as a huge chunk of your grade for quite a while, so you want to make sure that you get it in. Thank you, Itati. Thank you, Angelina. Smileys, emojis, yeses in the chat. Okay, Cody, if videos aren't working for you, you need to email me, and then I can make sure to send you the direct YouTube link. Okay. And then I also want to try to figure out why they're not working for you. So I can send you the YouTube links in the meantime and then try to troubleshoot why they're not working for you. So email me right now, that way I don't forget, because otherwise I won't remember. Okay. Now the cool part about projects though is that projects are not graded on a normal scale. All right. So they're actually graded on a 5 through 10 scale because I grade them on a rubric. And so this is actually to your advantage. So if you don't understand something, that gets graded as a 5. If you start to understand it, that gets graded as a 6. Higher levels get higher levels of grades, right? So 10 means you have perfect understanding of the concept. But this is actually to your advantage. That means the lowest grade you can get on a project is a 50%. And as long as you know a little bit on each slide, you will get a pretty good grade. So the majority of my students get A's on their projects. The rest of them tend to get B's on their projects. The only reason people don't get A's or B's on their projects is because they don't try on the project. So either they don't turn it in, or that when they do turn it in, it's filled with blank or random answers. So this is really important. In order to get the 5 through 10 grading scale, you have to provide a valid attempt. A valid attempt. That means that you don't have any blanks, and that means that you don't have any random answers in your project. It's very clear when you fill it in with random answers because the recording gives you every step, every instruction, goes over every slide, and often gives you a lot of the answers. So if there's an answer that's in the recording that you don't put into your project, that's a pretty clear indicator that you did not watch the recording, okay? And my goal with projects is not to punish you for what you don't know. It's to reward you for doing the best you can and for showing me what you do know. So that's why it's graded on a 5 through 10 scale. It's to your advantage. Just do your best. Just try. The more you try, the better you tend to do on the projects. Again, the majority of my students get A's and B's on them as long as they actually try on them. Yes, so technically, I know, Lexi, technically it's due tomorrow at 4 p.m. However, projects, I never zero them out until the following week. So you actually have a grace period where even though it's technically due tomorrow at 4 p.m., you don't have live class for me, so you should use this time to work on the project. Even though you don't technically have, even though it's technically due tomorrow, you can still work on it over the weekend. All right, go ahead, give me a green check, orange X, everyone, if you understand that. Again, there is a grace period. I understand that sometimes projects don't always go according to plan, so there is a grace period. All right. All right, looking good. I did want to go ahead and introduce Mr. Bangle to you. I don't know if he's ready to talk right now, but Mr. Bangle is going to be a sub that is taking over for our previous teacher. This is his contact info up here, so I'll go ahead and give him a moment to talk to y'all.
Yes, hi. Apologies for that. I just had to attend to something really quick. Yeah, so I'm your sub for your previous teacher. Me and Mrs. Larkin are co-teaching the same class. So half of you are on my roster, half of you are on her roster. But this is going to be super exciting. I'm basically going to be here for the rest of the year and then carrying over a little bit into the summer. Yeah, and I am super passionate about science, and I think this is going to be really fun. So looking forward to it.
Awesome. Thank you, Mr. Bangle. Go ahead and welcome Mr. Bangle, everyone, in the chat. While we're doing that, I'm going to go ahead and talk about our objectives for today. We are talking all about graphing today, so we'll talk about the purpose of graphing and talk about some different examples. We're going to actually do some graphing together, so we'll label the axes of a graph and plot the data. And then we're going to go ahead and talk about scatter plot versus bar graphs. We will be working on the 1F notes, so at this point, if you don't already have them open, I need you to go ahead and open them. What I want us to think about is we are going to be talking about graphing today, so let's go ahead and review graphing just in general. We're going to be connecting graphing to our science class, but first, let's just talk about graphing in a regular class in general, okay? So the question is, how would you graph the following data points? All right, so we have XY data points where the X's go along the X-axis and the Y's go along the Y-axis. So let's go ahead and first talk about one of these together. So let's take a look at 3, 7. All right, so hold on, I'm going to go ahead and take a look here first. All right, Angelina just going too fast here. So if I take a look at the 3, all right, the 3 is my X point, and so this one is where I should start at the bottom. So I want to start with the 3 at the bottom. Smiley faces or emojis in the chat box if that makes sense. Yeah, science is really just math applied. So you'll get some math in our class, but it's definitely, I don't think it gets quite as complex as your other math classes. Cool. Now, once we start at the 3, we then want to take a look at what's going on the y-axis, which here is the number 7. So on the y-axis, we have the number 7. And if I take a look at where those meet in the middle, right? So I go over and I go up. Then this right here would be my plotted point for 3, 7. Go ahead and give me a smiley, medium, or sad face if that's beginning to make sense. Again, you look at where the 3 is on the horizontal x-axis, and you look at where the 7 is on the vertical y-axis. Yeah, it's just math in disguise. It's true. It's true. Green checks, everyone, smileys, mediums, or sad faces, if that makes sense. Tim, Brianna, Lexi, Caden, Alan, Jaime, Seraphim, Edwin, Joseph. Awesome. Looking good. All right, so what I want us to go ahead and do is actually try out the other one. All right, so let's go ahead and on the whiteboard, please use your pointer tool, because otherwise we're going to end up with really messy drawings on the board. Use your colored pointer tool, that second arrow, and point for me, where do you see 6, 5? Again, take a look at the 6 on the bottom, the 5 on the left. Where would those meet? Where would those meet? Beautiful, seeing lots of people there. Yes, awesome. So we see our 6 on the bottom, we see our 5 on the left. Right, so 6 on the horizontal axis, 5 on the vertical axis. And so yes, they would meet right here. Beautiful. All right, let's go ahead and then try the next one. So 10, 2. Again, take a look at 10 on the x horizontal axis and the 2 on the vertical y-axis. Go ahead and point for me again on the board. Where would we find 10, 2? Where would we find 10, 2? Thank you. I see 6 people up on the board so far. Let's get some more participation up there. Make sure you're using your colored arrows. There we go. Now we're getting enough people. Beautiful. Yes, so we see 10 on the bottom. We see 2 on the left right here. And where they meet would be right here. Perfect. Excellent job. All right, go ahead and give me a green check, orange X if you feel like you're pretty comfortable with graphing. Again, that's going to go ahead and make sure that we are able to connect this to our science today. Excellent. I have almost 50% of my green checks. Tim, Brianna, Jalen, green checks. Caden, Juan Carlos, Jaime, green checks, if this makes sense. Seraphim and Mallory, green checks, everyone. Looking good. All right, let's move on here. So why do we graph things? All right, so in math class, we often graph things because they're like, you need to graph this data, right? It doesn't mean a whole lot, right? But in science class, graphing has a purpose. So the reason that we do graphing, I'm not saying it doesn't have a purpose in math class, but a lot of times the data is just kind of random data. Whereas in science, the graphing allows us to actually show a pattern between our independent variable and our dependent variable. We learned about these yesterday, right? Independent variable is what we choose to change at the start, so choose to change at the start of our experiment, whereas our dependent variable is the result that we're measuring at the end. Result that we measure at the end. Now, connecting it to graphing, the independent variable should be graphed on the x-axis, the horizontal bottom axis, whereas the dependent variable should be graphed on the vertical y-axis, the up and down one. That's usually on the left side of the graph. So we're going to go ahead and take a look at a couple examples of these. So remember that we talked yesterday about an example of hours of sunlight and the height of the plant. Sorry, 2 days ago, I think. Now, in this instance, our scientist was in control of what? Were they able to control the hours of sunlight the plant got or the height that the plant grew to? Tell me in the chat box. What were we able to control? The hours that we put the plant into sunlight or the final height of the plant? Tell me in the chat. Yeah, the hours of sunlight. So since we could control the hours of sunlight, right, we have control over this, then tell me in the chat box, is this our independent variable, IV, or our dependent variable, DV? Go ahead and tell me in the chat. Again, think about the word independent, the word dependent. Which one has the most control? If you are independent or dependent, when do you have control? Control. So a dependent is like a child. Do children have control over all their choices? Do children have control over all their choices? No. So this is actually the independent variable. Again, adults are considered independent, and so they have control over their choices. Same thing in an experiment. Independent variable is what you have control over. Yes. Now we just said if it's the independent variable, it needs to be graphed on which axis? Again, based on what we just learned, independent variable should be placed on which axis, the x or the y? Just take a look at our definition right here, x or y. Where does the independent variable get graphed on? Thank you, Angelina. Thank you, Lexi. Get some more answers in the chat. Again, practice it. Even if you have the same answer as 10 people above you, it still helps you to practice it. Again, you're the only one in control of your own learning. Yeah, it gets graphed on the x-axis. That's what we just learned. Okay, now again, connecting back to yesterday, now I need to know on the whiteboard, go ahead and box for me, the height of the plant, all right, is that the independent variable that we change at the start or the dependent variable that we measure at the end? And therefore, should it be on the x or the y axis based on our definitions over here? Go ahead and circle the correct terms for this last statement. Go, go, go. Get your answers up on the board. Answers up on the board. Beautiful. All right, I see lots of good answers up there, and I totally agree. Again, height of the plant is the result of this experiment, right? It's dependent on what happens in the experiment. Yeah, you can use the box tool or the pen tool, Lexi. It's totally fine. You can even point. I know some people have issues with different tools up there because Neuro is interesting like that. Neuro is unique. All right. So yes, this is our dependent variable, and as we just learned, dependent variables get plotted on the y-axis. Go ahead, give me a smiley emoji or a yes in the chat box if this is beginning to make sense. We're going to continue practicing it, so it will continue to make more and more sense, but just right now, are we beginning to understand? Thank you, Itati. Thank you, Joseph W., Angelina, Edwin, Cody. Wonderful. All right, so these are the answers to 2, 3, and 4. So number 2, you should fill in the blank with the word pattern. Number 3, you should choose the option that says independent variable and x-axis. Number 4, you should choose the option that says dependent variable and y-axis. Make sure you read these ones correctly because you do need the correct combination. So independent variable and x-axis for number 3. Number 4 is dependent variable and the y-axis. Go ahead and raise your hands for this one. I'm going to go ahead and give you a whole 60 seconds because there are 3 answers. Go, 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 raise your hands. Go, 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 raise your hands. Let's go ahead and actually try this out. So we talked about how our hours of sunlight, right, is our independent variable, and our height of our plant is our dependent variable. We said our independent variable needs to go on the x-axis, and our dependent variable needs to go on the y-axis. Okay, so I'm going to go ahead and label this for us, right? So on our axis, we're going to go ahead and put the hours of sunlight. And on our y-axis, we're going to go ahead and put our height of the plant in centimeters. All right, and let me go ahead and turn that for us. Woo, just like that. Okay, so I'm going to go ahead and we're going to do the same exact thing. Please use your pointer tool. That's this tool right here. And we're going to go ahead and work together on graphing this. So the first data point, 1, 3, point for me on the board. Where would I find that? So we want to start with the 1 on the bottom, which is our x-axis, and the 3 on our y-axis. Where would I plot that? Go ahead and show me up on the board. I see 2 people, 3 people. Use your colored arrows. I need lots of people up on the board. Again, practice, practice, practice. Helps to improve your skills. Beautiful. Yes, I would agree here. Absolutely. Here we go. All right, so I helped you out with that one a little bit. Let's try the next one. So 2, which is on our x-axis, and 4, which is on our y-axis. Go ahead and show me where would 2, 4 be. Where do you think 2, 4 would be? All right. Blue arrows, move over, move over. There we go. Perfect. Yeah, exactly. So over 2, up 4. Yes, that's going to be this dot right here. Beautiful. Let me go ahead and change colors here. What about 3, 5? So 3 hours of sunlight on the x-axis, 5 centimeters on the y-axis. Where would I find that? Where would I find that? Yep, so 3 hours here, 5 centimeters here. That would be right here. Perfect. And next one, 4, 7. 4 hours on the x-axis, 7 centimeters on the y-axis. What are we seeing? Oh, sorry, I did see all of those. Sometimes when I let students in, the tools glitch out. Yeah, so that one would actually be right here, right? So if I take a look here at 4 hours of sunlight and 7 centimeters high, that would actually be here. And what's our last one? Show me up on the board. At 5 hours on our x-axis and 9 hours on our 9 centimeters on our y-axis, where would that be? Where would that be? Beautiful. So I have 5 on the bottom here and 9 hours on the top here. Great job there. That looked amazing. Go ahead, give me a green check, orange X if you're feeling even more confident with how to graph and beginning to connect it to our science class. Thank you, thank you, thank you. Green checks, Tim, Brianna, Callie. Green checks, Kaden, Allen. Or red X's, again, orange X's if you don't understand, obviously, because I want to make sure we help you if you don't understand something. Beautiful. All right, so this is an example here. So we identified the independent variable, put it on the x-axis. We identified the dependent variable, put it on the y-axis, and then we just graph the points. So that looks amazing. Let's go ahead and keep going. Yeah, that's what we like to hear, Angelina. So here we go. Water depth is we're taking a look at this data now. We did talk about this data the other day where we related water depth and temperature. So again, tell me in the chat box, what do I have control over? Do I have control over where I'm measuring the water depth or the temperature at that depth? Go ahead and tell me in the chat. What do we have control over? Water depth or temperature? Depth or temperature? Yeah, so we can control where we measure, right? So if I can control where I measure, oops, come on, tools. All right, again, I have control over where I measure. Go ahead and box on the board for me. Would that be the independent or the dependent variable? Again, think about who has the most control in their life. Someone who's independent or dependent. Go ahead and box or circle. Use your pen tool. Whatever you need to do, point for me. Whatever you need to do to get your answer up on the board. And make sure you are participating. Thank you, thank you. Amari, I see you in the chat. Beautiful. Yeah, awesome. So absolutely, that is our independent variable, right? So this is going to be our independent variable. And we learned independent variable gets graphed on which axis? Which axis does the independent variable get graphed on? Go ahead and show me up there. I see 2 people up on the board so far, 3 people. Let's get some more people. If you need to, you can respond in the chat. Which axis should the independent variable go on? Yeah, perfect. Thank you, Amari, in the chat. Yes, this is going to be our x-axis, our horizontal one. Great. Let's go ahead and try temperature then. Go ahead and circle both of the correct terms here. Process of elimination. Temperature is what we're measuring at the end. This is the result we measure. And so does that make it independent or dependent? And which axis? Yeah, so absolutely this will be our dependent variable. Dependent because it's dependent on what we did in the experiment. And it should be placed on the y-axis. Beautiful. Let's go ahead and actually practice this. So you can see here, I put our water depth, our independent variable x-axis on the x-axis right here. And our dependent variable, our temperature, on the y-axis over here. Let's go ahead and try some graphing up on the board. We need 50 meters on the x-axis and 18 degrees Celsius on the y-axis. Where would that be? Where would that be? Point for me on the board. I love the encouragement in the chat box, Angelina. We need more of that in our lives, don't we? Get your answers up on the board. Awesome. I see 7 people up there. Let's go, let's go. If you don't have your arrow up there, make sure you do. All right, yeah, so 50 meters right here on the bottom. 18 degrees here on the y-axis. So yes, this would be our first point. Go ahead and show me our second point. 75 meters on the x-axis, 15 degrees on the y-axis. Where would that be? Where would that be? We have not yet done question number 5, if that's what you're asking, Jonathan. We did 2, 3, and 4. Yes, awesome. So here is 75. 75 is right in between, all right? So 75 is actually right here. And it's at 15, right, which is also right in between right here. So I know this one is a little bit harder, but I think most of us still got that. That's actually right here. Awesome job on that one. All right, let's go ahead and try 112. 100 meters and 12 degrees Celsius. 100 meters and 12 degrees Celsius. There we go. Changing colors up here so we can see it. Yep, here's 100. Here's 12. Perfect. I think we've got this. Go ahead and draw the rest of them for me. Draw the rest of them for me. Grab your drawing tools. Draw the rest of them for me. Where do we find 150 and 5, and where do we find 204? Go ahead and actually use your drawing tools and draw the dots for me. Draw the dots for me. There we go, perfect. I see our 150. Let's go ahead and do our 204. 204. There we go, beautiful. Perfect. Excellent. All right, so that was our second practice one. How do we feel about that? Give me a smiley, medium, sad face. We practiced how to identify the axes, and we practiced actually doing the graphing. Great, amazing. Tim, green checks. Brianna, green checks if you're feeling good about this. Callie, Jalen, Alan, Kamal, Benjamin, Jaime, sorry, green smiley faces. Matthew, Mallory, thank you, Brianna. Perfect. All right, let's go ahead and move on to talking about our different types of graphs. Now, the types of graphs we've been looking at so far are what are called scatter plots. And scatter plots are pretty familiar to us because of math class, right? Where we have two sets of numerical data and we graph that data, right? The XY scatter plot, that's literally what we just did a whole bunch of times, okay? Now, scatter plots are useful, again, when both of your data, both the start and end data, is numbers or numerical data. The cool part is that once you graph this data, you can actually draw a line and you can actually see a pattern for that data if such a pattern exists. So taking a look here, you can actually see the pattern here. So I can draw a trend line here and see the pattern. And taking a look at our plant, right, I can see a pattern here. Smiley faces, emojis in the chat box if you understand, if that makes sense. Again, trend lines, graphing, the whole point of graphing is to see if there is a pattern. See if there is a pattern. Cool. Now, bar graphs can also be very useful. Bar graphs, however, don't necessarily have two sets of numbers, and therefore they can't necessarily be graphed in the same way because they're not mathematically related. So bar graphs, I agree, are fun. They instead have rectangles of different heights, and those rectangles represent different categories. Again, we would use a bar graph when we don't necessarily have two sets of numbers, right? So like over here, age and number of emails are both number data, whereas over here, a type of movie is not a number. And so it makes more sense for me to use a bar graph, right? So comedy, action, romance, those would be my different categories. They're not mathematically related to each other, okay? So this is the answer to number 5 and the answer to number 6. Fill in the blanks with what you see in red and raise your hands. You have 30 seconds. Go, go, go. If you're having trouble, just communicate. For this question right here, I want to know on the whiteboard what would make more sense for us to use. What type of graph should we use? So here we go. We have a kind of flower, rose, tulip, lily, orchid, forget-me-not, and the number of flowers. So would it make more sense to use a scatter plot or a bar graph? Go ahead and circle for me up on the board. Which would make more sense? Which would make more sense? Again, when we talk about scatter plots, we're talking about mathematical data. Sorry, mathematical. When we talk about bar graphs, we're talking about our categories. Yeah, excellent. Looks like we're all saying bar graph, and I would totally agree with that. Again, here we don't have two sets of numbers, so I can't graph them as a scatter plot. I could only graph them as a bar graph. Go ahead and try the next one, temperature and ice cream sales. Go ahead and circle the correct answer up there for me. Excellent. I see Jonathan. I see Lexi up on the board. I see Amari in the chat. Matthew working. Edwin, thank you. Perfect. I see some arrows up there too. Absolutely. This one would make more sense as a scatter plot because in this case, we do have numbers for both of our data, both our independent variable and our dependent variable. Go ahead and give me a green check, orange X, if you understand the difference between scatter and bar, scatter plots and bar graphs. Amazing. All right, y'all, this is going to be the answer to, come on slides, please move. This is going to be the answer to number 7. Please fill in that blank with the word bar space graph. Okay, make sure you spell it as you see it up here. And number 8, the answer is scatter plot. Make sure you spell it as you see it up here. Otherwise, the computer will not mark it correct. All right, so this is number 7 and number 8. You have 40 seconds to go ahead and fill in both of those and raise your hands. Raise your hands. This last one, you need to go ahead and do on your own. So the question is, what type of graph would make the most sense for this data and why? All right, so the question is, so here you go. You actually need to have 2 correct answers here. So you need to first decide, is it going to be a scatter plot or a bar graph? And then why? Which one has to do with categories that are not mathematically related, and which one has to do with numbers that are mathematically related. If you don't remember, those answers are from number 5 and number 6, right? So if you don't remember, you can refer back to your notes, refer back to notes number 5 and number 6 for those definitions of scatter versus bar graph. Okay, so this is going to go ahead and be number 9. If you want to check your answer, we're in the Q&A area. All right, I'm going to go ahead and give you 30 seconds to work on this one. Again, you should have 2 correct answers. 2 correct answers. Again, identify which type of graph, and then what's the definition of that type of graph. You can go ahead and submit that, all right, and then let me know on the whiteboard, how are you feeling about this? Let me know on the whiteboard, how are you feeling about these topics? All right, go ahead and submit that. As soon as you submit it, I'll correct that last problem. Again, I apologize, the key for that last problem was incorrect, so I will fix it. Excellent, awesome. I'm glad you guys are feeling amazing on that. That's what I love to see. Go ahead and submit that, and I will see you all later. Don't forget to watch the recording for tomorrow to make sure that you finish up your project. Again, it won't be zeroed out till next week. You have a bit of a grace period, but try to do as much of it as possible tomorrow so that you're not overwhelmed later.